Okay, here's a couple of the problems from chain rule practice number 2. First one I'm going to do is number 2, and the reason I picked number 2 is because this problem illustrates the difference between that exponent with the trig function. So we need to realize that in this first term it's the tangent of x squared, whereas in the second term it's the quantity tangent x squared. So really, when we're looking at our inner and outer functions, in that first term, the trig function is the outer function, the x squared is the inner. In the second term, the squared is the outer, the tangent x is the inner function. So our derivative, taking the derivative of each term, working from the outside to the inside. So first term, derivative of tangent is secant squared x. Well, this time our x is that quantity x squared. Now since I have more than just an x, or my inner layer, x squared also has a derivative. The derivative of x squared is 2x, and I'm going to go right ahead and write it out in the front. So that first term, I've done everything I need to take the derivative. I had two functions, I have a product of two derivatives. So it's plus. Now here I have two functions. First I'm going to evaluate the power rule, so it'll be 2 tangent x to the first, which is just tangent x, times, now working my way to the inner function, derivative of tangent x is secant squared x. And there's not much I can do with that. I could factor out a 2, and that's it. I can't factor out a secant because this one is secant of x squared and this one's secant x. So that is done. Okay, the next one I was going to do was number 5. So number 5, which says that f of x equals quantity x minus, instead of 1 over x, I'm going to write that x to the negative 1 to the 3 halves. So when I'm looking at this, I have two functions. I have the quantity in the parentheses is one function. Then I have this power of 3 halves, which is the outer function. So this derivative will come from first evaluating the power rule. So it will be 3 halves minus 1 will be 1/2. Now I need to multiply by the derivative of x minus x to the negative 1, that quantity that was the base of the exponent. Well, derivative of x is 1. The derivative of x to the negative 1, it'll end up with minus a negative, which will turn into plus x to the negative 2. Now I've evaluated all my derivatives. Now I'm just going to simplify this. I'll end up with 3 halves x minus 1 over x to the 1/2 times 1 plus 1 over x squared. It's written as factors, so that's good. I'm done. The next one I'm going to do is number 11. Y equals sine cubed of the quantity 2x plus 3. So here we need to realize that cubed, I'm going to scribble it out because it's the outside function, so I'm going to rewrite it like this. So I have 3 functions here. I have the cubed, I have the trig function, and then I have this 2x plus 3, the linear function that I'm taking the sine of. So I'll have a product of 3 derivatives. Working outside in, I'm going to take the power rule first. Now working my way to the next layer, which would be the trig function. Derivative of sine is cosine. Then my last inner layer would be that 2x plus 3, which has a derivative of 2. Now I'm just going to neaten this up a little bit. So the derivative of y with respect to x will be 6 sine squared of 2x plus 3 times the cosine of 2x plus 3. And that's it. Hope you guys are finding these easier. Keep practicing, you'll get it.